Hey Opties! Today we're talking about coordinate transformations, specifically with rigid transformations. And that includes translations, which is a slide, reflections, which are flips, and rotations, which are turns. We are going to be talking about them on the coordinate plane, which means we're going to be talking about X and Y pairs to talk about the points of some figures that we might do some rigid transformations of. So let's go ahead and take a look at that. First, we have translations, and a definition of that is from pre-image to image. We are translating some sort of distance in the X direction. It could be to the left or the right, and that's what the A in the X direction means. And we're doing some sort of distance of B in the Y direction, and that could be up or down. So let's go ahead and look at our translation rule. XY goes to X plus A, comma, Y plus B. Again, A could mean we're going left or right. Left if it's negative, right if it's positive, and B means we're going up or down. Up if it's positive, down if it's negative. Let's define a translation rule for these two triangles here. And let's just say that this bottom triangle is our image. So let's label it A, B, C. Therefore, we have A prime, B prime, C prime. And remember, the primes, those little tick marks on the after the letters, just showing us that that is the image, which means it's the figure we get after we've done some sort of transformation, in this case, the translation here. So we're gonna match up pre-image to image points and see what happens to our points to figure out our translation rule. So clearly we are going up, right? So how much are we going up is the question. So we could just pick this Y value here because up is changing our Y values, and find the corresponding Y value on that B prime. So from -6 to 4, you're going to increase 10. And if you want to check to see if that works with the other points, you could check those. From -2 to 8 is also an increase of 10, and from -5 to 5 is also an increase of 10. So our translation rule will be starting with just our regular old points of our pre-image, and then we're going to keep our X's the same. If you notice, the X values are the same for all of our corresponding points. And then we're going to be adding 10 to our Y, and that is our translation rule for vertical, our first example. Our second example is a horizontal translation. So we're going to be going either to the left or to the right. Let's just call this right figure our pre-image this time. So we'll call it A, B, C, and then we have A prime, B prime, and C prime. So we are going to be going left here, and let's figure out how much. If we're going left or right, that's going to be affecting our X values. So let's look at those. From A to A prime, we go from 5 all the way over to -7, and that's going to be left 12. Let's check with our B to B prime just to be sure. From 4 to -8, that's left 12 as well. And then from 9 to -3 is also left 12. So we're going to start with our regular XY points on our triangle ABC. And then what we will do to each point is we're going to subtract 12 from our X value, but we'll keep our Y values the same. And that again shows that it's a horizontal translation. Thirdly, for our translations, we have a diagonal translation. So that means we're going to have a change in our X and our Y. So let's just label this bottom left our pre-image, and then the top right our image. So again, I'm just marking those points with our letters here. So let's just start with, and I might write it down here because we've got a little bit more going on. You could certainly look at the graph too, but let's just start with A, and that's -7, -2. And then we go to A prime, or if you want to draw a little arrow to remind yourself that you're translating here, and we go to 5, 8. So what happens from -7 to 5, how much do we increase? And that's an increase of 12. So our change in x has got to be an increase of 12. And let's figure out our change in y. From -2 to 8 is an increase of 10. So we should be going right and up. And if we look back at our images, that is true. And let's actually draw it on our graph just to be sure. So we should be going right 12. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And let's count up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we do end up at A prime. So that's awesome. And let's just finish out writing our translation rule. xy goes to x plus 12 and y plus 10. And again, the x plus 12 means we're going to go right 12, and the y plus 10 means we're going up 10. Next we have reflections, and we're just going to look at 3 different types of reflections. A reflection over the x-axis, y-axis, and the line y equals x, which is just a line, so a linear function of slope 1 and y-intercept 0, and that's dotted in our third picture. Next we have reflections. Starting off with our reflection over the x-axis, each x value stays the same and each y value becomes the opposite sign, which we can see here in our reflection statement. So let's just take a look at our image. I am drawing over the x-axis because that is our line of reflection. So let's look at our coordinates. Notice the x's do stay the same. -7 and -7, -8 and -8, -3 and -3, and we have swapped signs for our y values. So let's go ahead and do our A, B, C, and then we're gonna have A prime here, B prime here, and C prime here. So if we would connect our points on our triangle to the line of reflection, we see that it's an equal distance. This is a distance of 2. This is a distance of 2. And it's perpendicular to this line of reflection. So remember, we've talked about this before, when we make 2 segments that are congruent to each other and they're created by perpendicular lines, then that's called a perpendicular bisector. So we could put tick marks to show those are congruent. And we could do the same thing with our B and B prime to that x-axis. So that's just a little piece of information that any reflection line is the perpendicular bisector of those corresponding points meeting that reflection line. And we'll reiterate that in just a moment as well. Next, let's look at our reflection over our y-axis. So we see here that each x value becomes the opposite sign and each y value stays the same. So similar to our x-axis reflection, but kind of like swapped in its rule. Now the thing that's negative are our x's. And so let's show our y-axis, bold that a little bit. That is our reflection line, and if we connect corresponding points, we see that these go together. A prime, B prime, C prime. We are still making those congruent segments. So we could make our tick marks if we would like to. So we're making those congruent segments. And the whole time they are all perpendicular to that reflection line. And that's even so over here with a diagonal line of reflection. And what's cool about the reflection over the line y equals x, which remember I said has a slope of 1 and a y-intercept of 0 if you're thinking about slope-intercept form. We have a cool pattern where y and x swap places. And I kind of like to think about it as y equals x is the same thing as x equals y. So they can swap order and it's still the same thing. So let's connect. If we're going to make these two segments congruent, they have to go perpendicular to our reflection line. And this helps if you're trying to draw an image of reflection, if you have the pre-image, it helps to know this rule. It makes it a lot easier to do a reflection, even if you didn't remember the reflection rule and just knew that it was going to be equidistant from that reflection line and perpendicular to it. Next, we have coterminal angles and perpendicular bisectors, which of course is not a coordinate transformation, but it does have a lot to do with rotations and then our reflections, which we briefly talked about the perpendicular bisectors already. So for our coterminal angles, that just means that angles that sometimes go in different directions, but in general, for our purposes, they do go in different directions, such as clockwise versus counterclockwise, but they start and end at the same positions. So think about how we have 180 and negative 180. If they both start at this positive x-axis here, and they both end at this negative x-axis, like this point over here, they're still going the same distance, but they're just different directions. So we could argue that a rotation of this amount could be either of these. Next, we have 270 and negative 90. Again, a positive degree is the same thing as going counterclockwise, and a negative degree is the same thing as going clockwise. So that's what we see here. Still starting at the positive x-axis, which is typical if you're talking about coterminal angles. And we're ending at this same little point here, this same negative y-axis. And we've got those two different amounts and directions, but they still start and end at the same place, so they're coterminal. Thirdly, we have 90 degrees and negative 270 degrees. And that's the same thing as 90 counterclockwise, and negative 270 is the same thing as clockwise. And we have that image here, starting at the positive x-axis, ending at this positive y-axis here. So for our perpendicular bisectors, it's just a reminder that the line of reflection, which is the x-axis here, that's going to be a perpendicular bisector of the segments that connect the corresponding points. And we talked about that with the reflections earlier. We're gonna make those tick marks to show they're congruent. So this line of reflection is our perpendicular bisector. And remember, bisector means you're going to cut something into two equal sized pieces. So that perpendicular bisector. Lastly, we have our rotations. We're going to talk about three main types. You can have rotations of different sizes than these, but for these we do have special patterns for our coordinates that we can actually write a rotation rule for. (180) or negative 180 degree about the origin. So it's the first type of rotations we're looking at. The x values and y values will become the opposite sign. So they're just becoming negative if they're positive and positive if they're negative. So let's talk about, let's say this bottom left is our pre-image, A, B, C, and we've got to decide what's A prime, B prime, and C prime. Well, if you look, the signs have been swapped. So this has to be A prime, this has to be C prime, and this has to be B prime. And you might be able to tell that based on your visualizing that. Let's go ahead and mark our center of rotation, which is the origin. Remember, the origin is 0, 0. And remember, we can easily tell visually what the degree of rotation is if we connect our pre-image point to the center of rotation to the image point. So we see that that's a straight line, which it should be because we're doing that 180 or negative 180 degree rotation. So let's look at our points C to C prime. that makes a line as well. And B to B prime ought to make a line. Since they all do, it's a really good way to check that we do indeed have a 180-degree rotation, and that could be plus or minus, again, because those are coterminal angles. And an easy way to think about that is if you've got this line, that's going to be 180 degrees on the top or the bottom. So if you start here, that's going to be a positive 180 degrees, and this direction will be negative 180 degrees. Again, our rotation rule for that is just swapping the sign of X and Y. Next, we have a 270 or negative 90 degree about the origin rotation. Let's go ahead and start out by marking our center rotation here. And let's see if we could figure out, even if we didn't look at our rotation rule already, what kind of coordinate rule we would have. So it would seem that maybe this -7 and -2 go with the -2 and 7, since they have some of the same numbers here. So let's just mark those A prime. So let's try it and see what it looks like if we connect our pre-image point to the center of rotation, then to our image point. That looks like 90 degrees here and 270 on this side. So going clockwise, it should be 270, which is a good check because that's our positive. And going counterclockwise should be 90, which is a good check because that should be negative. So it's looking pretty good. And if we looked at our points, -7, -2, and then our point -2, 7, we see that the Y of our first point matches the X of our second. And then our X of our first matches the Y of our second, except for the signs change. So that's a good way to just verify that our rule is going to make each X value become opposite sign, and the X value and Y values will swap places. Lastly, we have 90 or -270 about the origin rotation. Let's mark that center. And let's pick the point -3, -5 as A. And that seems like it'd probably go with 5, -3. And let's map our points. So this angle is 90 and this is 270. I like to think about 90 as a fourth of my plane, my coordinate plane here. Like it's like one quadrant, and then 270 is like 3 quadrants, so it's like 3/4 if you want to think about it that way. So if we start at our left figure as our pre-image, that means that the 270 is going clockwise, so that should be a negative, which is true. And if we go counterclockwise, that's going to be getting our 90 here, which should be positive, which it is. So if we look at our -3, -5, that then goes to our 5, -3. Again, we've swapped our X and Y, and the coordinate that has changed signs now is our Y value has become positive. So that's changed its sign. So there is our rotation rule there. All right, Opties, that's it for our coordinate transformations, including translations, reflections, and rotations, with talk of coterminal angles and perpendicular bisectors. See you next time.